Hello, everyone. Welcome back to the session. My name is Abhishek, and I'm mathematics faculty here at askIITians. So this is lecture number 2 of the chapter Quadrilaterals of class 9th. And before we discuss the subtopics or before we discuss the topics that we are going to cover in this session, let us understand the weightage of this chapter, although we discussed this in our previous session as well. But let us revisit that thing once more. So if I talk about school examination, then in school examination, you can expect questions of around 3 to 4 marks from this particular chapter. And this chapter is more important because we use the concept of the quadrilaterals in other chapters of geometry as well. Okay. So the relevance of this chapter is more as we use this in other chapters as well. So it's very important for us to understand everything that we are covering here in this chapter properly. And if I talk about IMO, which is conducted by SOF, then you can expect around 2 to 3 questions from this particular topic. Okay. So that's the weightage of this chapter. So which topics are we going to cover in today's session? Let us check them. Let us discuss them, and then we will proceed ahead. So basically, we are going to discuss the proof of the properties of parallelogram. Okay. So there are 8 theorems that we have. I will give you the proof, the logic behind 4 or 5 theorems and the similar kind of theorems that I will be giving you as a homework as well. So it's very important for you to remain attentive while I discuss the proofs of all the theorems. Stop me wherever you feel you haven't understood any theorem. I'll be more than happy to explain that particular theorem again or whichever part you could not understand. Okay. So we have in total 8 theorems in your syllabus that we are going to discuss. All right. So this is your theorem number 1. What does theorem number 1 or property number 1 says? It says a diagonal of a parallelogram divides it into two congruent triangle. So we are provided that this figure ABCD, that's a parallelogram. Okay. That's a parallelogram. And what we have to show? You have to show that the diagonals, let's say here I am considering diagonal BD. So if I am considering diagonal BD, I have to show that triangle ABD is congruent to triangle CDB. Okay. Or if I am considering, let's say, diagonal AC, then I have to show triangle ADC is congruent to triangle CBA. Okay. So you can consider or you can take any one of the case to show that the triangles which are formed by considering the diagonal, they are congruent to each other. Okay. And we all are already aware of the different properties or the different rules that we have in congruency. Okay. So let me write what are we given. Here we are given that A, B, C, D is a parallelogram. All right. And what we have to show? We have to show that diagonals, we have to show, you can say, triangle ABD is congruent to triangle CDB, or you can say, you can show this also, triangle ADC that is congruent to triangle CBA. You can choose any one part here. Okay. So we are going to do one construction here. Construction is we are going to join diagonal. You can join any one of the diagonal, guys. So here I am joining diagonal BD. So we have joined this vertex B and this vertex D. When we joined it, we got this diagonal, which is BD, and E is the point of intersection of diagonal AC and BD respectively. Okay. So let's see how we can prove it actually. Okay. So I'm going to consider the two triangles which are formed as a result of joining diagonal BD. So if I talk about triangle ABD, in triangle ABD and triangle CDB, what do we have? This angle, because this line AB that is parallel to CD, and this BD that you have, it is acting as a transversal. So this angle that you have, this will be equal to this angle, alternate interior angle, right or not? You are going to have angle ABD that is equal to angle CDB. Okay. The reason is alternate interior angle. Alternate interior angles. Okay. And why we are saying this? Because AB is parallel to CD, as ABCD is a parallelogram, and this BD is acting as a transversal here. Okay. What is the other thing you have? This side BD that we have here, this is the common side. So you are going to have BD is equal to BD. So that is common. Understood? What's the third thing you have? The third thing is this angle that you have here. This is same as this angle. Okay. For the very same reason, because this line segment that you have DA, it is parallel to CB. And because DA is parallel to CB, as ABCD is a parallelogram and DB is acting as a transversal. So these two angles will also be equal because of the same reason, alternate interior angle. So you are going to have angle ADB, that is equals to angle CBD. Okay, the reason is similar, that is alternate interior angles. All right, so we have this. Therefore, we can say that this triangle ABD that you have, that is congruent to triangle CDB. By which rule? They both are congruent by ASA congruency rule. That is the angle, two angles, and the corresponding side. Two angle and the included side, I would say. Two angles and the included side of one of the triangle are equal to the two angles and the included triangle, included side of the other triangle. So we have shown that the two triangles that we have considered here, they are congruent to each other, or in other words, we can say we have shown that the diagonals of a parallelogram always divides a parallelogram into two congruent triangle. And always remember, if the two triangles are congruent here, then the area will also be same of the two triangles, because congruent figures means the figures which have exactly same shape and same size. And since the size is also same, therefore these figures are going to overlap each other. And because these figures are going to overlap each other, therefore the area which is contained by these two figures, that is also going to remain same. So this is the proof of this theorem number one, or the result number one, you can say. Please go through it and ask me if you have any doubt in this theorem. Please go through it. All right, is it done? Anyone has any doubt in this theorem yet? Okay, so check out the next theorem or the next property we have. What does this property says, or this theorem says? It says in a parallelogram, the opposite sides are equal. So we have to show that opposite sides that we have here, they are equal. So to show that AB is equal to DC, and you have to show DA that's equals to CB. You have to show these two parts. All right. And what are we given? We are given that ABCD is a parallelogram. You are given that ABCD is a parallelogram. That's what you are provided. All right. So to show what you have to do, we have to do one construction, guys. And the construction is similar to the construction that we did in last problem. Okay. Construction is you need to join any one of the diagonal. So let's say I'm joining BD. See, the proof of this theorem is very similar to the proof that we did of theorem number one. Okay, we joined BD. Now our goal is actually to show that this triangle ABD that you have, that's congruent to triangle CDB. Okay, so check out. In triangle ABD and triangle CDB. What will I have? This angle will be equal to this angle, corresponding angle, right? As this line is parallel to this line and DB is acting as transversal, not corresponding angle, sorry, alternate interior angle. So you have angle ABD that is equal to angle CDB. Okay, the reason is clear, that is alternate interior angles, right? After that, this side that you have, this common diagonal BD, like this side BD is common to both. So you can say BD is equal to BD. They both, like it is common in both the triangles. Understood? Apart from this, you have this angle will be equal to this angle, again corresponding angle, because DA is parallel to CB and DA is parallel to CB and this line is a transversal. So you have angle ADB that is equals to angle CBD. The reason is same, that is alternate interior angle. Okay, so we can say that this triangle ABD that you have, that's congruent to triangle CDB. By which congruency rule? By ASA rule. And because these two triangles are congruent to each other, then we can say that the opposite sides are equal by CPCT. So you can say AB is equal to DC and you will have AD is equal to BC by CPCT. CPCT means corresponding part of congruent triangle. Corresponding parts of congruent triangles. Understood? So that's it. So like till here, or I would say around 95% proof of this particular theorem is exactly similar to the proof that we did of the last theorem. It's just that in the end you have to add one more thing. You have to write that AB is equals to DC and AD is equal to BC by CPCT. That is what you have to mention, and then we will be done with the proof of this particular part. So please go through it, note it, and ask me if you have any query, guys. All right, done. Does anyone have any question or any query in this proof yet? Shall we move ahead? All right. So this theorem, the theorem number 3 that you have, this is the converse of theorem number 2 that we discussed. Okay. This is actually converse of theorem number 2 that we discussed. They are saying it's a parallelogram if opposite sides are equal. So here we are given, what are we given? You are given opposite sides are equal. You are provided AB is equal to DC and you are provided AD is equal to BC. This is what you are provided. And if this is provided to you, you have to show that this figure is a parallelogram. You have to show ABCD is a parallelogram. That's what you have to show in this. Is that clear? So this is again quite easy to prove, isn't it? The construction needs to be done here as well. What is the construction? Construction is, let's say I join any one diagonal. I'm joining BD here. If I join BD, I have two triangles now. So I'm going to consider triangle ABD and triangle CDB. Okay. So in these two triangles, what do I have? I have AB is equal to DC, that is given to me. I have AD is equal to BC. So these two things are given to me already in the statement. Okay. And apart from this, we have one side common, that is BD is equal to BD. If you see very clearly, that's common. So it can be said that these two triangles that you have, they are congruent to each other. Okay. So you can say triangle ABD that you have, that is congruent to triangle CDB, okay, by triple S rule. And if these two triangles are congruent, we can say this angle is equal to this angle by CBCD, this angle is equal to this angle by CBCD, and therefore the opposite sides will become parallel as well. So we can say angle ABD that is equals to angle CDB, and you will have angle ADB that is equals to angle CBD, okay, by CPCT, okay. But they are alternate interior angle, correct or not? But they are alternate interior angles, right? And because the alternate interior angles are equal, therefore you can say AB is parallel to DC, and you will have AD is parallel to BC. Otherwise, that is not true. And because the opposite sides are equal and parallel, therefore you can say that this figure you have ABCD, that's a parallelogram. Is that clear to everyone? It's a parallelogram. That's it. This is what we were supposed to show. So please go through it. Ask me if you have any query or any doubt in this proof, and I'll be more than happy to discuss it. I will be giving few theorems to prove to you as well, guys, so that you can actually think what all you can add or subtract, or what construction you can do from your side to make the proof, like to actually derive the result. So I'll tell you which theorems you have to do as a homework. Right, done. Shall we move ahead, or is anybody having any doubt? Okay. So we have now the next theorem. What does this next theorem says? This next theorem says if in any parallelogram, the opposite angles are always equal. Okay. So here, what are we provided? We are provided ABCD is a parallelogram. ABCD is a parallelogram. All right. And what do we have to show? We have to show that angle A is equals to angle C and angle B is equals to angle D. That is what we have to show, because these are the opposite angles. So A needs to be shown equals to C, and we need to show that this angle B that you have, that's equals to angle D. Understood? So let's see the proof. All right. See, we all know that whenever we are talking about parallelogram, in any parallelogram, the opposite sides are always parallel. Okay. So we know that here you have AB is parallel to DC, and you have BC is parallel to AD. Correct? Therefore, can we say that the sum of angle A plus angle B, that will be equals to 180 degree? Because this line that you have AD, that is parallel to CB, and this line AB is acting as a transversal. Therefore, the sum of this angle and this angle will be 180 degree, because these are co-interior angles, right? These are co-interior angles, right? Similarly, this line AB is parallel to DC, and this line BC is transversal. Therefore, the sum of this angle and this angle will be 180 degree for the very same reason. Okay. So also we have angle B plus angle C, that's equals to 180 degree for the very same reason that these are co-interior angles. Okay. Now the sum of A and B is 180 degree. The sum of B and C is 180 degrees, so we can equate them, right? So from 1 and 2, what do we have? From 1 and 2, you will have angle A plus angle B, that will be equals to angle B plus angle C. You can cancel angle B on both the sides. So what will you get? You will get angle A is equal to angle C. So we have shown our first part, that is angle A is equal to angle C. If you use the same logic, right? If you use the same logic, that means you write angle A plus angle D is 180 because these are co-interior angles as the opposite sides are parallel. D plus C is 180. Sorry, A plus D is 180. B plus A is 180. Again, for the very same reason, co-interior angle, the lines are parallel. You equate them. You can easily show B is equal to D. Okay. So we can write similarly. Similarly, what do we have? Similarly, we will have angle B is equals to angle D, correct? And that proves our theorem. Okay, hence proof. So what we were supposed to show in this theorem, we were supposed to show that if you are given any parallelogram, then in that parallelogram, the opposite angles are always going to be equal. That means angle A will be equals to angle C and angle B will be equal to angle D, and we have done that. Done? All right. So now we have converse of theorem 4, which says a quadrilateral is a parallelogram. A quadrilateral is a parallelogram if opposite angles are equal. So this is converse of theorem number 4 that we discussed just now. So what are we provided here? We are provided angle A, opposite angles are equal. That means angle A is equal to angle C and angle B is equal to angle D. That is what we are provided. And what do we have to show here? We have to show that ABCD is a parallelogram. ABCD is a parallelogram. That is what we have to show. So it's quite easy to show. See, this ABCD, that's a quadrilateral, right? ABCD, that's a quadrilateral. And because it's a quadrilateral, the sum of all the four angles of this quadrilateral will be equals to 360 degree. Okay. So in quadrilateral ABCD, if I add all the four angles, I'll be getting A plus B plus C plus D, that's equal to 360 degree. Correct or not? So angle C I can replace by angle A. Correct? Angle D I can, or angle B I can replace by angle D. So I will be having angle A plus angle D plus angle A plus angle D is equals to 360 degree. And we got this result from 1. Let me call that 1. So we got this from 1, right? So we have 2 times angle A and 2 times angle D here. So you have twice of angle A plus twice of angle D. That's equal to 360 degree. Understood? You can take 2 common. If you take 2 common, you will be getting angle A plus angle D. That's equals to 360 degree. Correct? You can divide both the sides by 2. If you divide both the sides by 2, you will get angle A plus angle D is equal to 180 degree. Okay? Angle A, that means this angle and this angle, the sum is 180 degree. But these are co-interior angle, and if the sum of co-interior angle is 180 degree, the sides are going to be parallel. Okay, so what do we have here? But these are co-interior angles. Okay, therefore you can say that AB will be parallel to DC. Understood? So we have shown AB is parallel to DC. Similarly, we can show for the other angle also. We can show A plus B is equal to 180 degree and AD will be parallel to BC. If that happens, automatically this figure which is given to you, that will get converted into a parallelogram. Okay. So similarly, Similarly, we are going to have AD is parallel to BC. Okay. Therefore, from 2 and 3, if I call this 2 and this one as 3, so from 2 and 3, 2 and 3, ABCD is a parallelogram. Understood? That's what we have. Is that clear? Please go through this proof. Ask me if you have any query. You can say the proofs are very easy. It just, yeah, for the very first time, you might feel like they are not very direct. But yeah, when you will practice it once, they will become very easy to you guys. Let me know when done. Done. All right. So now we have this theorem that in a parallelogram, diagonals bisect each other. Diagonals bisect each other. So what are we given here? We are given that ABCD is a parallelogram. ABCD is a parallelogram. Okay. That's what we are provided. And what do we have to show? We have to show diagonals bisect each other, or you can say AC and BD bisect each other. Bisect each other. So that's what we have to show. So this is, I believe, the easiest theorem out of all. What you have to do is you have to consider triangle ABE. Okay. So in triangle AEB and triangle CED. Okay. In these two triangle, what do we have? We can say angle BAE, that is equals to angle DCA. That means this angle is equal to this angle DCE, I would say. Okay. Alternate interior angle. Alternate interior angle, because these two lines are parallel to each other. Okay. And AC is transversal. Similarly, these two angles will be equal to one another. Okay. So you will have angle ABE, that will be same as angle CDE, for the very same reason, alternate interior angles, as the lines are parallel, and here this line is going to act as transversal. Apart from this, you have AB is equal to DC. Okay. Why? Because these are opposite sides of a parallelogram, right? So we can say that these two triangles are congruent to each other by ASA rule. Okay. Therefore, we can say triangle AEB, that is congruent to triangle CED by ASA rule. Okay. And because these two triangles are congruent to each other by ASA rule, so we can say that this ED or BE will be equals to ED. So you will have BE is equal to ED. And what else will you have? You will have AE is equal to EC. Okay. Right. And this proofs our result by CPCT, hence proved. Okay. Because this shows that the diagonals are bisecting each other. That's it. All right. Is everybody done? Okay. Now we have the converse of this theorem that we just discussed. Okay. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So I have to draw a parallelogram here, guys. Let's say this is A, B, C, D, and the diagonals of this quadrilateral are is like they are bisecting each other. That is, let's say O. So DO is equals to OB and AO is equals to OC. So we have, what are we given? We are given in quadrilateral A, B, C, D. Okay. AO is equals to OC and you have DO is equals to OB. That is what you are given. You can call it your result number 1. Okay. What do we have to show? We have to show that it's a parallelogram. Okay. To show ABCD is a parallelogram. All right. So check out how we can do it. I am going to consider triangle AOB and triangle COD. So in these two triangles, you have AO is equals to OC. You have DO is equals to OB. These two things are given to us. All right. And apart from that, what do we have? This angle will be equal to this angle, vertically opposite angle. So you have angle AOB that is equal to angle COD, vertically opposite angle. So what can be said? Therefore, we can say that this triangle AOB that is congruent to triangle COD by SAS rule, right? SAS rule. And because these two triangles are congruent by SAS rule, we can say that this angle is equal to this angle by CPCT, right? So we can say angle ABO that's equals to angle CDO by CPCT. Understood? And because these two angles are equal to one another by CPCT, but these are actually alternate interior angle. Okay, but they are alternate interior angles. All right. So what can be said? So we can say that this line AB that is parallel to DC. Okay. This line AB is parallel to DC. Similarly, we can show that this line DA that would be parallel to BC, and if because AB is parallel to DC, AD is parallel to BC, so this figure will automatically become a parallelogram. Okay. Similarly, what do we have? Similarly, we have DA that is parallel to CB. Okay. So what can be said? We can say that this figure ABCD is a parallelogram. Understood? That's done. Is it done? Does anybody have any doubt in this? No doubt? All right. So now we have a quadrilateral is a parallelogram if its one pair of opposite sides is equal and parallel. Okay. So let's say we have AB is parallel to CD and we also have AB that is equals to CD. All right. So what are we given here? We are given uh, in quadrilateral ABCD. We have AB is parallel to DC and we have AB that is equal to DC. All right. What do we have to show? We have to show ABCD is a parallelogram. ABCD is a parallelogram. All right. So let's see how we can do it. Okay. So we are going to consider two triangles. We are going to consider triangle ABD, okay, and we are going to consider triangle CDB. So in triangle ADB and triangle CDB, all right, what do we have? We have AB is equals to DC. That is given to us, okay. And because these two lines are parallel, therefore this angle will be equal to this angle, alternate interior angle. So you will have angle ABD, that is equals to angle CDB, alternate interior angle. Alternate interior angles. Okay. Apart from this side is common to both. So what do you have? You have BD, that's equals to BD, that is common. So if you look very carefully, we can say that these two triangles that we have considered here, they are congruent to each other by SAS rule. Therefore, it can be said that triangle ADB, that is congruent to triangle CDB by SAS rule. Okay. And because these two triangles are congruent to each other, it can be said that this angle is equal to this angle by CPCT. All right. So it can be said that angle ADB, that's equal to angle CDB by CPCT. CPCT, right? But these two angles are actually alternate interior angle. And because they are alternate interior angle, then these two angles will be true only when these two lines are parallel. Okay. But they are alternate interior angles. All right. Therefore, what do we have? Therefore, we have AD is parallel to BC. Now, what is happening? We are already given AB is parallel to DC. We have shown AD is parallel to BC. So what can be said? It can be said that this figure ABCD that you have, that's a parallelogram, and that proves this particular theorem. All right. Please go through it. Go through it. Ask me if you have any query. So these are the 8 theorems or 8 properties, you can say, of the parallelogram that are there in your syllabus. We have discussed the proof of all the 8 results that we have in our syllabus, and I hope you all got it. uh, just make sure that you practice them at least once or twice to get a good hold over it. Try to understand it rather than cramming it. If you understand it once, believe me, you will never forget it, and you can easily do it even without revision. So please go through it before I tell you the application of these theorems that we discuss in the problems. All right, done. Okay. So now we have one problem. Let's see what are we provided and what they are asking us to show. We are given a parallelogram ABCD that you can see angle A is 90 degree. We have to show all the other angles are 90 degree. That's very easy, right or not? So you have to show all other angles are 90 degrees. So I have to show angle B, angle C, angle D, and angle A all are 90 degree. See, as ABCD is a parallelogram, okay? As ABCD is a parallelogram, therefore opposite angles will be equal. So if angle A is 90 degree, angle C is also going to be 90 degree, okay? Therefore, you will have angle C is equal to angle A, right? Because opposite angles of parallelogram, we studied this theorem just now, opposite angles of a parallelogram. And because opposite angles are equal, we can say that angle C is going to be 90 degree. Why? As we are already given angle A is equal to 90 degree. Okay, that we are given. So we have shown angle C is 90 degree, right? Now, in any parallelogram, the sum of co-interior angle is always 180 degree because it's a parallelogram. So AB will be parallel to DC, and this line is going to act as transversal. So as AB is parallel to DC and CB is a transversal. CB is a transversal. Okay. So what will you have? Therefore, we can say angle B plus angle C. That's equals to 180 degree, right? Co-interior angle. And because these are co-interior angle, now we can put the value. So you will get angle B is equal to 180 degree minus 90 degree because the value of angle C is already given 90 degree. So what is the value of angle B you got? The value of angle B you got is 90 degree. Understood? So we got this angle to be 90 degree. Clear? And again, opposite to angle B, what do we have? We have angle D. So angle D is also going to be 90 degree because these are opposite angles of a parallelogram, right? So now you have angle D that's equals to angle B, opposite angles of parallelogram. Opposite angles of parallelogram. All right. So what will you have? Therefore, you can say angle D will be equal to 90 degree as well. Okay. So we have shown angle C is 90 degree, angle B is 90 degree, angle D is 90 degree, and that's exactly what we were supposed to show in this problem. Please go through it. Ask me if you have any doubt before we discuss one more problem. Okay, done. All right. So this is the solution for your reference, guys. You can check it out. Opposite angles are equal, therefore angle C is 90 degree. The adjacent angles are supplementary, so from there they got angle D 90 degree. And because D and B are opposite angles, so finally we got angle A is equals to B is equal to C is equals to D is equal to 90 degree. And this parallelogram which they have given, it's actually a rectangle. That was a cricket pitch. We all know cricket pitch is rectangular in shape. So now we have one more. What does it says? It says in a parallelogram ABCD, AC bisect angle A and C. So that means we are given in parallelogram ABCD, we have angle 1 is equals to angle 2 and you have angle 4 is equals to angle 3. Okay. What do we have to show? We have to show AC is perpendicular to BD, or basically we have to show that any of these angle is 90 degree. All right. So let's discuss the proof. So in triangle ADC and triangle ABC, what do we have? We have angle 2 is equals to angle 1. Okay. Angle 2 is equals to angle 1, that is given to us. All right. We have this side AC common in both. Okay. AC is equals to AC, that side is common in both. All right. We have angle 4 is equal to angle 3. Angle 4 is equals to angle 3, that is also given. Okay, not common, that is given. All right. So it can be said that these two triangles are congruent by ASA. So triangle ADC, that is congruent to triangle ABC by ASA rule, right? So these two triangles are congruent to each other by ASA rule. And because these are congruent, then we can say that AD is equals to AB by CPCT. So what do we have? So it can be said that AD is equals to AB by CPCT. All right. So this is a very important result which we got here, guys, because we are going to use it. Now, we are going to consider this triangle and that triangle, triangle ADE and ABE. So in triangle ADE and triangle ABE, what do we have? We have AD is equals to AB. AD is equals to AB. That is that is from 1. We showed it. Okay. Clear? Angle 1 is equals to angle 2. That is already given. All right. What is the third thing? The third thing is we have a common side. So we have AE is equals to AE common. So these two triangles are congruent to each other by SAS rule, right? So you have triangle ADE that is congruent to triangle ABE by SAS rule. And because these two triangles are congruent to each other, therefore this angle and this angle will be same by CBCT. Okay, so you will have angle AAD that will be equals to angle AEB, and I'm going to call them, let's say, X. Okay, by CPCT. But these two angles, if when you add them, the sum is going to be 180 degree, as these are linear pair or the straight angle that is formed. Okay, so but if you add AED plus AEB, what will you get? You will be getting 180 degree, right? Because of linear pair angles, right? Now I can substitute the value of these two, right? If I substitute the value, what will I get? I will get X plus X is equal to 180 degree. So what will I get? I will get 2X is equal to 180 degree. And eventually I'll be having X is equal to 90 degree. X is equal to 90 degree means what? That means angle AED, which is same as angle AEB, is equal to 90 degree, right? And if these two angles are 90 degree, what can be said? Therefore, we can say that this AC that you have, that is perpendicular to BD, and that completes our proof of this particular question. So please go through it. Ask me if you have any doubt in any of this step. I'll be more than happy to explain. All right, done. Okay, so this solution is for your reference, guys. You can refer it if you want to. They have also shown the exact same thing. So these two questions you have to try as a homework, or these two questions are for your practice, guys. These two are proving problems. So you have to use the properties that were discussed in today's session. Using those properties, try to prove these two problems. In case you are not able to prove it, please get in touch with your subject expert, discuss it, and he will certainly be able to help you out. So before we end this session, let us quickly go or rediscuss what all we covered in today's session. We covered 8 important theorems, or you can say the results. We covered the proof of all the 8 results, or all the 8 properties or theorems, whatever you want to call it, as well as we discussed the application of them as well. So what you have to do, you have to revise all those theorems once at your home, practice more and more problems, and you will eventually get command over this topic. So that is it from this session. Thank you so much. I'll see you in the next one. Goodbye.